So here's the second part of the study guide. So these are the exponent rules, which we have spent a lot of time on. Make sure you etch these into your brain, or at least get them written down on your index card that you can bring to the final. So don't remember. Don't forget, that's what I meant to say. If you are multiplying two variables together that are brought to different exponents, in order to simplify that, you simply add the two exponents and you keep the same base. The power rule, so this is a little different because you have an x to some to some power, but that's all in parentheses, and you are taking that whole expression to another exponent. So you have to multiply a times b to simplify that. Quotient rule, if I'm dividing, then I'm always subtracting the top exponent. I'm subtracting the denominator exponent from the numerator. Last but not least, the negative exponent rule, and this is again one that can cause a little bit of chaos into an otherwise pretty straightforward problem, is anytime I see a negative exponent, I take the reciprocal. I think of it as 1 over x to that same positive exponent. Likewise, if I had 1 over x to the negative a, in order to turn that positive, I would bring the whole thing upstairs. I think we've talked a little bit about if you have someone really negative in your life upstairs, that you want to put them in the basement, even though that's not very nice, but maybe give them a little space and maybe they'll turn positive later. So if it's a negative exponent, bring it downstairs to get it positive. And don't forget your 1 on top. Okay. When you're combining like terms, which is generally speaking when you are adding and subtracting different terms, which is monomials is a fancy term for, you're looking for terms. If you think about it, if I have 2x plus x, these are like terms. They are x terms. I have coefficient of 2, a coefficient of 1 here. So I now have 3x. This is the same thing that you've been doing over the past month, but this is just a little less complicated. Likewise, if you have 2x squared plus x squared or something like that, you're going to end up with 3x squared, right? And you'll see me a lot of times if it's a more complicated, oh man, I wrote on this. Oh, if it's a more complicated problem, that I will underline the like terms just so I remember. And I'm adding them together, so I'm not like getting rid of these. I think some of you, if this were a subtraction problem, right? So if it were 2x squared minus x squared, well, they are like terms. I don't cancel the x squareds out though. Really what this means is I have 2 of this thing and I have 1 of this thing, which means I just have 1 of that thing left over. Okay, so don't change the exponents and don't get rid of the variables. Okay, if you look at 1, so this could have been a little tricky. Don't forget that, first of all, they are like terms. 6 minus 8 is negative 2. And I'm holding on, right, to the like term. Don't get rid of that like term. Keep it. Number 2. Here are my like terms. I have an xy squared, xy squared. So I'm going to go ahead and combine those. And I have, that one's going to be by itself because there's nothing else to combine that with. So when I combine 6 and negative 2, I get 4. So I'm going to hold on to that term, the rest of that stuff, and I'm going to hold on to this whole thing. I didn't change anything about that. Over here, I'm subtracting, and again, here's this thing, right? I'm subtracting this term from this term. This is what has to go first. So I put that first, and I'm subtracting a negative, if you think about it, which means I'm going to add them. I'm going to end up with 14 because 8 plus 6. And I'm going to have the same term. So I could keep the b to the 5th power. Number 4, I'm now multiplying. So this is a different world. So if I'm multiplying terms together, this is when first of all, I'm going to multiply the coefficients. 7 times 5 is 35. I have a negative, 1 negative, so it's going to remain negative. And then I have n and then I'm going to, if you think about it, I am adding these two exponents here. -4 plus -2 is -6. Okay, it's getting smaller. Then when I simplify this, always hold on to the coefficient. Whether it's negative or positive, it's still a whole number. Don't suddenly put it in the denominator. A negative number is not the same as a fraction. Don't forget that. So if it's negative or positive, a whole number, keep it on top always. What I'm putting in the basement is n, though, to the -6 down here. Okay. Number 5. So I have 5 squared. That's where I got my 25. So 5 squared, 4, and I'm multiplying 4 times 2 because that is our power rule. And I get, I guess that's a v. It's funny. Not used to v's. V to the 8th times, and then I have 2, if you think about it, times 1, v, which is still 2, but I'm still adding this invisible exponent of 1. So I have v to the 4th. Now I can further simplify it because I have 25 times 2, which is, I know, 50, and then I get to add my v values, which is 8 plus 4, which is to the 12th power. So they're getting a little more complicated as we go. Now over here I have a -a to the 6th power raised to a power of 2. 6 times 2 is 12. It's an even number exponent, so I'm going to get rid of that negative sign. And then I have b to the 1st power raised, so it's going to be to the 2nd. Now I am adding, so I have to watch out for like terms here. And guess what? They are like terms, so that's makes it easy. So I have my invisible 1, so 1 of this whole thing plus 9 of this whole thing equals 10 of the whole thing. And I hold on to that term. 7. So I have -2 y to the 4th. I didn't do anything to that. Times, and then I'm taking this to a power of 2. So I'm squaring everything in here. So x squared y to the 6th because I'm multiplying these two numbers. And then I'm subtracting. So I have to be mindful again of like terms. I have 13x squared y to the 10th. Now, if you look at this, which is kind of cool, is that when I combine these two, these are going to be, if you think about it, y to the 10th, right? Because I'm basically multiplying the y values and I'm going to add the exponents. Got it? Okay. So I end up with -2y to the 10th times x squared. And by the way, this means the same thing as this. I was just trying to prove that. So they are, in fact, like terms because this equals -2x squared y 10th. Okay. And then -13 plus -2 is -15x squared y to the 10th. This is a lot of stuff that I can just go ahead and cancel out. So these cancel each other out. 7 minus 4 is 3. And then 6 minus 5 is 1. I end up with r. Taking -3, I'm squaring it, so I'm going to end up with 9. And then I have x to the 12th all over. I'm going to multiply these terms together, 15. And then I add those two exponents, x to the 6th power. And I'm going to end up with this fraction. Now, don't forget, if I were to have divided 9 by 15, gotten a decimal or something like that, it's not wrong. But for sake of this problem and this test and this unit, just go ahead and simplify the fraction. Look for a common factor. So I know that both of these are divisible by 3. So 9 divided by 3 is 3, because now in essence I'm simplifying this fraction. 15 divided by 3 is 5. And then I have these x's. So I have 12 minus 6, and that will give me 6. So that's where I get that. And if you had written 3x to the 6th over 5, that would also be the same thing. Okay, over here I have 4 squared, so I should get 16. And then 4 times 2 is 8. 2 times 2 is 4. all over. Remember, everything is being squared. So that not only just the numerator, but the denominator too. 6 squared is 36, x squared, y squared. And then I'm going to simplify. So I already know that I can divide both of these numbers by 4. So 16 divided by 4 is 4, because I'm going to simplify this fraction. 36 divided by 4 is 9. And then I know that 8 minus 2 is 6, and 4 minus 2 is 2. Multiply the coefficients, I get 21. K, now I have negative 8, if you think about it, plus negative 2, so it's going to be in the negative, even more negative. So it's negative 10. Hold on to that value. I can go ahead and divide both of these by 3. They have a common factor. So I'm going to simplify the fraction into 7 over 2, and then negative 10 minus 2 gets me more into the negative territory, right? Which is going to be negative 12. So if you think about, before I got this answer, right, if I had 7 over 2 and then k to the negative 12, and then I'm going to stick negative 12 onto the bottom and turn it positive. That's how I got that. Okay. Number 12 is I have, first of all, I have, on the top, I have n to the 8th, and I have negative 9, and it's all over this number. I'm going to go ahead and simplify. 9 over 27, I know it fits in 3 times, so I end up with negative a third, and then 8 minus 10 is negative 2. Now I'm going to play around with this. So keep this fraction intact. Don't do anything to it. So keep it over here. Negative a third, that's what that means. But all I did here is I brought the negative 2 down here. But don't suddenly bring this fraction like all down or all up. Keep it intact. A to the 12th, b to the negative third, all over. So I'm taking a to the negative 4th, b to the negative 4th. I can do some simplifying here. I'm going to end up with a 16th, and then so the negative third minus the negative 4th is just adding, so it ends up being b, just one of them. 14, I'll just show this. What makes this tricky here, I'm combining these terms here, like I have the 7 plus 5, I have the 6 plus 9, 15, and I'm subtracting, so I got to look for my like terms again, right? I'm taking a half to a third, which is going to get smaller, to an 8th. M to the 12th, n to the 15th, and good thing, see? They're like terms. So I'm subtracting 1/8 from 3/4, which gives me 5/8, and I'm holding on to that same term for the rest of that stuff. Here is this final problem. I'm just going to show you. I have negative 4 squared. Get rid of my negative 16. I have 6. X to the third, y to the 12th. And I get to hold on to this whole term. And then here I'm just going to start simplifying it. I end up with, you name it, like terms. Hold on to my like terms, add 16 and 7, voila. Bye.